Okay, so for this one, we have a sample of a compound is 52.9% aluminum and the rest is oxygen. So we only have two compounds in this one, and that is going to be aluminum, and then we have oxygen. So we are starting from a percent, so we're going to have to do that fancy step where we start with the 52.9%. We're going to take that percent and we're going to scribble it out and replace it with a G for grams. But then we look down here and it says the rest is oxygen. So we got to do a little extra thinking there. It's not too bad, but we're going to look at this and we say, okay, well, if 52.9% is aluminum, then we know that percent means out of 100. So that means 52.9 plus something is equal to 100. So we're going to take 100 minus that 52.9 in order to figure out the remaining amount of oxygen. So we're going to say 100 minus 52.9. So that tells me that 47.1% is going to be oxygen. So 47.1% is oxygen. So then we move on to our next step. We take that, cross it out, we're in grams. Okay, then we have to convert our grams to moles. So we're going to go ahead and set up our little T-chart. Grams is going to come down to the right, and we're going to be converting into moles. We know that for 1 mole, it's the molar mass. So I'm going to refer to my periodic table. And aluminum is 26.982. 26.982. Okay, and then for oxygen, we're going to also take the grams down to the right. So this is grams of oxygen. We want moles of oxygen. So just like we did up here, we're going to have 1 mole is equal to the molar mass, which is 15.999. Again, that's coming from the periodic table right here, 15.999. All right, so once we have those set up, we're going to go ahead and convert both of these to moles. So when we go to type in our aluminum, we're going to say 52.9 times 1, push enter, divided by 26.982. If you remember in the previous video, I did tell you that the shortcut is just automatically divide it by the molar mass. That's what we end up doing. So for this value, we get 1.96 and looks like 0.5, so we'll go up to 1. 1.961, okay? And technically, actually, we could have gone down to 3 significant figures. So I'm going to go ahead and scribble out this one. Actually, we'll erase it. There we go. We should be going to 3 significant figures on this. Okay, so this one down here, I'm going to go ahead and calculate, and we're going to have 47.1 divided by 15.999. I get 2.94. So now that we're already in moles, we're going to divide both of these by the smallest, which is this value up here. So we're going to say divide by 1.96, divide by 1.96. This one is going to equal 1. This one I'm going to type into the calculator. So 2.94 divided by 1.96. We end up with 1.5. So there is that infamous 1.5 thing, right? That 0.5. So remember, these things end up being subscripts, right? So if we were to go with just these values that we have, we would have aluminum 1, oxygen 1.5. This is weird. We don't do that. So what we're going to do is we're going to go ahead and say, okay, this needs to be fixed. So what's a way to get rid of 0.5? That would be to multiply it by 2. Whatever you do to one, you have to do to the other, because you're basically kind of keeping them equal, I guess, in regards to how much, what you're adjusting them to. So we're going to double both of these. That's the way to think of it. We're doubling both of them. So we end up having a 2 for this one, and we'll have a 3 for this. So that leaves us with Al2O3 as our final answer, which is aluminum oxide.